In today's video, we're going to discuss how to factor a trinomial when there are two variables involved. The steps are pretty much the same as before, except that it looks a little bit funny because there are two variables. So, quick refresher, the first thing you always want to do is check for a GCF, a greatest common factor. Make sure that the binomial is written in standard form, and I put standard in quotes this time because it looks a little different. The two squared terms should be at the ends, and the term with the two variables should be in the middle. So your trinomial should look something like this: ax squared plus bxy plus cy squared, where a, b, and c are constants. Now you may not have x and y, but the important part is you have the squared term first, the squared term last, and the term with both variables in the middle. We're going to multiply a and c together just like before. We're going to find the factors of the product AC and then determine which of these factors add up to be b. We're going to rewrite the expressions with the factors replacing b, and then we're going to factor by grouping. All right, so example 1, we have this trinomial. My first constant is a 1, so my leading coefficient here is a 1. So I need two factors of negative 18 that add up to be 7. So I can start running through the different factors of 18. I could have negative 6 and 3, but I add those together and I get negative 3, so that's not it. I could have negative 2 and 9. Negative 2 plus 9 is 7. So that's going to be the two factors that I'm looking for. So I bring down the m squared. I split the middle term into a minus 2mn and a 9mn. And then I bring down the minus 18n squared. And then I can factor by grouping. So I'm going to group together m squared minus 2mn plus 9mn minus 18n squared. My greatest common factor in the first group is going to just be m. So I have m, and then I have m minus 2n left. My greatest common factor in the second group of 2 is going to be a 9n, and that means I'm left with an m and a minus 2n. So again, these two factors match, so that's going to be the first factor, m minus 2n, and then my second factor is going to be the sum of the leftover pieces, m plus 9n. All right, example number 2. I have 5m squared plus 40mn plus 75n squared. First thing I want to do is check for a GCF, and in this case I have one. I have 5 as a GCF. So factor out the 5. m squared plus 8mn plus 75 divided by 5 is 15, so I have 15n squared. So my leading coefficient inside the parentheses is a 1. So I need two factors of 15 that add up to be 8. And my two factors of 15 that add to be 8 are 3 and 5. So I'm going to split this middle term. So I have 5 parentheses m squared plus 3mn plus 5mn plus 15n squared. And I'm going to factor by grouping on the inside. So I have 5 m squared plus 3mn plus 5mn plus 15n squared. GCF of my first piece is going to be just m, so I have m and then m plus 3 left over, plus GCF of the second piece. I can factor out a 5 and an n, so left over is going to be m plus 3n. And then I'm going to write my final answer. So I have 5, which is the GCF. I have the shared factor, m plus 3n. There should be an n hanging out in there. Sorry about that. And then the sum of the leftovers, m plus 5n, as my final answer. All right, example 3. No GCF in example 3. However, I have a leading coefficient other than just a 1. So the first thing I'm going to do is I'm going to multiply a and c. So I have 8 times 6. 6 times 8 is 48. So I need factors of 48 that add up to be 49. And those two factors are going to be 48 and 1. So splitting up the middle term, I have 8a squared plus 48ab plus 1ab, or just ab, plus 6b squared. Factor by grouping, so I'm going to group the first two, 8a squared plus 48ab, plus group the second two, ab plus 6b squared. And I'm going to factor out the GCF. So the GCF of 8a squared and 48ab is going to be 8a. So I'm left with a plus 6b. And then my GCF of the second two terms is going to be just b. So that means I'm left with a plus 6b. So my final answer will be the product of the matching factor, a plus 6b, and the leftover pieces. So a, 8 times a plus b. For the last example, I'm going to scoot down just a little bit. All right, so I look here to see if I have a GCF, and in this case I do, and I believe that it is 9. Let me just grab my calculator. All right, so 54 divided by 9 is going to give me 6. 192 divided by 9. Oh, nope, that doesn't work. Let's try 6. 192 divided by 6. So I'm going to have a GCF of 6. So this is going to be 9x squared minus 32xy. And 96 divided by 6 gives me a minus 16y squared. So GCF of 6 factored out. Then I'm going to take the product of the first term and the last term, and I'm going to kind of work this down here at the bottom where I have a little bit more space. So I'm going to have 9 times 16, which is going to give me a negative 144. So I need factors of a negative 144 that add up to be negative 32. Well, I know I have 12 and negative 12, but those two are not going to add up. So let's see, 144 divided by 16. So I have negative 9 and positive 16. That's not going to work. Positive 9 and negative 16, add those together. That's not going to work. I could do 24 and 6. So negative 24 and positive 6. That's not it. What about... let's see, 18 and 8. That one also doesn't work. What else could I divide 144 by? So sometimes this process is a little bit lengthy. Let's see, how about 48? So I could have 48 and 3. That's still not giving me 32. Let's see. About 9 and 16. Nope. Aha, here it is. I have a negative 36 and a 4. So notice, trial by error. And again, it could take a while. So I have 6 on the outside, and then I have 9x squared minus 36xy plus 4xy minus 16y squared. I'm going to factor that by grouping. So I have 6, and in my first group I have 9x squared minus 36xy. In my second group I have 4xy minus 16y squared. Find the GCF of the first group. So the GCF of 9x squared and 36xy is going to be 9x, leaving me with an x minus 4y plus GCF of the second group is going to be 4y. And then I am left with x minus 4y. And my final answer will be the GCF times the shared factor times the sum of the leftovers, 9x plus 4y.